All right, let's talk about a really fascinating new player that's just hit the AI scene, Qwen 3.5. Now, this isn't just another language model. It's something different. It's a model that can see, understand, and even act on what it sees, and it's all thanks to a clever architecture designed to solve one of the biggest headaches in AI.
And that headache is a classic trade-off, one you've probably felt yourself. Do you want power, or do you want speed? For years, making an AI smarter meant making it slower and way more expensive. It's a choice that has put the most powerful models out of reach for pretty much everyone. But what if you didn't have to choose?
So let's just dig into this problem for a minute. It's often called the impossible trade-off, and for good reason. It has been a massive roadblock for innovation in this space for a long time.
Here's how it works. As these big frontier AI models get smarter, their appetite for computing power just explodes. We're talking exponentially. That means sky-high costs, insane energy consumption, and a huge barrier to entry for developers and companies that don't have bottomless budgets. This is the exact problem that Qwen 3.5 was built to tear down. So, enter Qwen 3.5. It's an open-source model that aims to give you the best of both worlds. Top-tier, frontier-level intelligence, but with the speed and efficiency of a much, much smaller model. So how on earth does it pull that off? Well, the real magic here is in its architecture. There are two key innovations that make this whole thing work, and the first one, it's a real game changer.
You know, most AI models you hear about are dense. You can think of it like a single giant brain where every single neuron has to light up for every single task. It doesn't matter if you're writing a poem or solving a complex math problem, the whole brain works on it. It's powerful, sure, but it's incredibly wasteful. Qwen 3.5 uses what's called a mixture of experts, or MOE architecture. And this is way more like having a board of specialist advisors. A task comes in and the model is smart enough to say, okay, for this, I only need my math expert and my logic expert. It routes the problem to just the handful of specialists who are best for the job, while everyone else just sits back and saves energy.
And just to give you a sense of the scale we're talking about, the main Qwen 3.5 model has a massive library of knowledge, clocking in at 397 billion parameters. This is what gives it that frontier-level intelligence. But here's the kicker. This is the really clever part. While its total knowledge base is absolutely enormous, for any given task, it only ever activates about 17 billion of those parameters, just the experts on duty. So you get the intelligence and the nuance of a nearly 400 billion parameter model, but with the speed and the cost of a much smaller 17 billion parameter one. That is a huge deal. Okay, so that's trick number one. The second big idea is its hybrid attention architecture. The best way to understand this is to think about how you read, right? Sometimes you're just skimming a document to get the gist of it, but other times you slow down and really deep read a specific sentence to understand a critical detail. Qwen 3.5 is designed to do both. Let's break down how this works. It combines two different types of attention. Most of its layers, in fact 3 out of every 4, use something called gated delta networks. You can think of this as a super efficient way to skim information quickly. Then for every 3 of those skimming layers, it has 1 layer of traditional full attention, the kind you find in big models like GPT, for that deep reading, for understanding really complex relationships. This 3-to-1 hybrid design is the key to its speed. And the payoff is insane. We're talking up to 19 times faster decoding than older models.
So you've got this amazing combination of MOE and hybrid attention giving Qwen 3.5 its incredible speed. But a brilliant architecture is only half the story. To really unlock its potential, especially its ability to see, it had to be trained in a fundamentally different way, not just on text, but on our visual world.
See, a lot of older multimodal models use an approach called late fusion. It's kind of like they bolted a separate vision module onto a text model. That module looks at an image and basically whispers a text description of it to the language model. Qwen 3.5 uses early fusion. It was trained on images and text together, right from day one. So it's not translating. It genuinely sees and reads at the same time. It's the difference between being told what's in a picture and actually seeing it for yourself. It leads to a much, much deeper understanding.
And pulling this off required some seriously next-level training techniques. We're talking trillions of high-quality, heavily filtered data points. Their infrastructure was so efficient that training this incredibly complex multimodal model was almost as fast as a text-only one, and they used cutting-edge techniques like asynchronous reinforcement learning and something called FP8 precision, which cleverly cuts the memory needed for training in half, boosting speeds by over 10%.
So, what happens when you combine this hyper-efficient architecture with this native multimodal training? Well, you get something pretty special.
You get an AI that doesn't just see the world, it can actually act in it.
This is what we call a visual agent. It's an AI that can literally look at a screen, your desktop, a mobile app, a website, understand what all the buttons and menus are, and then actually use them to get things done just like a person would.
And the process is just so intuitive, it's beautiful. First, the AI sees the screen. Then it understands the different elements. Okay, that's a submit button, that's a text field. Then it plans the steps it needs to take to do what you asked, like book me a flight. And finally, it acts. It literally executes the clicks, the typing, the scrolling. This isn't science fiction. This is built right into the model.
And it works incredibly well. The benchmarks show that it's seriously capable of controlling desktop operating systems, navigating around in mobile apps, and automating really complex tasks on the web. This is a massive step forward for AI-powered automation.
And it's not just a one-trick pony. Qwen 3.5 is a true all-rounder. It's got state-of-the-art performance in things like complex document understanding, advanced math reasoning, coding, and it supports an incredible 201 languages.
Okay, so the tech is awesome, no question, but let's bring this all back down to earth. For you, as a developer or researcher, what does this actually mean? Is this the right model for your next project?
This right here is probably the most important part. When you put Qwen 3.5 side by side with the big proprietary models, you see something amazing. The performance? It's right there at the frontier level, shoulder to shoulder with them. But then you look at the inference cost, and because of that MoE architecture, it's dramatically lower. And then, crucially, you get to the license and the ability to self-host, and that's where the story gets really interesting. That's all thanks to its Apache 2.0 license. Now, this isn't some restrictive community license with a bunch of gotchas. This is complete freedom. You have unrestricted rights for commercial use, for modification, for distribution. It democratizes access to this top-tier AI, letting developers build and innovate without being locked into someone else's ecosystem.
Okay, now for a quick reality check. While it's open, that doesn't mean you can run it on your laptop. To self-host the full-fat version, you need about 800 gigs of VRAM, which means an enterprise-grade GPU cluster. Even a compressed 4-bit version needs a beast of a machine like a Mac Studio Ultra. So while self-hosting is an amazing option to have, for a lot of people, using the official hosted API is probably going to be the more practical choice.
So when you boil it all down, the equation for Qwen 3.5 is pretty simple. You're getting the intelligence of a massive frontier model, plus the speed and efficiency of a small one. And then you're adding this groundbreaking ability to see and act as a visual agent.
This unique combination of power, efficiency, and real openness, it really has the potential to change the math for developers everywhere. It breaks down those barriers we talked about at the start. So the only question left is, what are you going to build with it?